Hello, welcome back to Cinderella Math. Today we're going to be doing quite a few things here. We're going to learn how to take a fraction to a decimal to a fraction, and then compare and order sets of fractions and decimals like all mixed together. I would recommend having your basic calculator or cell phone calculator, or if you're a online calculator, I love the Desmos one. I will show by hand, but then I'm also going to use that online Desmos calculator. If you are an online calculator person, you can do the Desmos Scientific or the Graphing. Either one's fine. I'll show both. If you're not allowed to use calculator, like if your teacher says you're not, then I will show by hand as well. Alrighty. So let's go ahead and get in. We're going to start by converting fractions, or excuse me, decimals to fractions. All right. Alrighty. So out of the two conversions, I think this one is easier. I mean, they both have pros and cons, but yeah, this one is easier. So example one, I'll do several here on this page. Let me just go ahead and set this up. Right. So let's have 0.9. And now that's how we say it just every day. Like if I was just, reading something on my phone and that number came across, I would say 0.9 or 0.9. But think of your place value. Back in elementary school, you learned place value hundreds, tens, ones, dot, tenths with the THS, hundredths, thousandths, right? So technically, it is 0.9, but the technical name for this is 9/10. And it's the technical name that's going to help us write the fraction. So just write 9/10. Reduce if possible. That one does not reduce, and you're done. Okay, so kind of have to think about the technical name of a fraction. Let's do this one. Let's do 0.14. So again, that's kind of the normal way to say it, 0.14 or 0.14. But then the fancy way, this is tenths, this is hundredths. So the, mathematical way to say this would be 14 hundredths. Right? If this is your change after you buy something at a store or a restaurant, they're giving you back 14 cents. And it takes 100 cents to make a dollar here in the United States anyway. That's where I'm based. So that's 14 out of 100. That's what they're giving you. 14 out of 100. So 14 hundredths. Now this one can reduce. They're both even. So let's divide by 2, which would give us 7/50ths. That would be your best answer, the reduced one. Let's bump it up a little bit. Example 3. Let's have 0 and 475. So again, 0.475 is probably how most of us say that, but that's tenths, that's hundredths, that's thousandths. So the fancy way would be 400. If I could spell, that would be good. 475. You don't have to write this, by the way, unless that's part of your assignment to like write it out in words. Thousandths with the TH. So all we're going to do is 475 over 1,000. So that place value that you learned back in elementary school is really important here. Now that does reduce. I think we can divide by 25. You could, of course, use a calculator if you're allowed to. I'm going to forget about example 4 and come on down. So I am going to grab a calculator here. If you're not allowed to, just grab some scratch paper and long divide. But that's going to be 19 over 40, and that does not reduce anymore. So that would be your best answer. But the place value got us started, and then we just reduced. Now you'll notice that I did all of those had a ones place of 0. We can do it when it's not 0. So this will be my example 4. let me do 3.47. So again, if I was just reading something on my phone, or I don't know, if I was at the grocery store and you have to weigh your apples and I bought 3.47 pounds of apples, that's how I would say it. But again, the formal way would be 3.47 so hundredths. It's always the last place you say. So we would write the whole number 3, because I bought 3 whole pounds of apples, and 47 hundredths. Okay, I am not going to convert these to mixed number, or excuse me, that is a mixed number. I'm not going to convert it to improper. If you need to, go ahead. I have another video doing that. Feel free to just look on my channel. It should be in the middle school math playlist, but I'm going to leave that right now. Okay, let me do another one of those. Example 5. Going to do 18.94. So again, that's the kind of normal way to say it, but the technical way would be 18 and 94 hundredths. Now the last one, the 47 hundredths did not reduce. I think this one's going to. So this is 18 as a whole number and 94 hundredths. Again, I'm not going to convert these to improper. We're going to leave it as a mixed number. But this one, they're both even, so I am going to divide by 2. So keep the 18, and when we divide by 2, I know the bottom's 50, and the top is 47, I think. Yeah, and now that does not reduce any further. That's the best answer. Okay. And now if you are in middle school, you probably do not go any farther than the thousands. So I'm going to just do one more with the thousands place. So the fancy way to say that would be 3 and 153 tens, hundredths, thousandths. So you always go with the last one. So your fraction would be the 3 is the whole number and 153 over 1,000. We usually don't put the comma in fractions. You're not wrong if you do, but I wouldn't. Right? I will do, if you're in high school, again, usually high school, we don't usually go a lot bigger than that, but just for kicks and giggles, I'll show you just one bigger. If you're in middle school, you can fast forward this or just watch for fun. Oh, I don't think the red one, I don't think that reduces. You should check, but it doesn't. There's nothing you can divide these by. Okay, so there's my fraction there. Or excuse me, there's my decimal. And my task is to turn it to fraction. Tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. So this would be 123,456 out of a million. And again, you don't have to, it's not wrong if you leave out those commas, but it's fine if you put them in. Now that probably does reduce. They're both even. So it is definitely going to reduce. So I would just grab a calculator. The bottom, a million cut in half, is 500,000. And the top, I'm just going to use my calculator. Cut in half is 61,728. They're both still even. I'm going to divide it again. I know the bottom is 250,000. Oh my gosh, this is still even. 30,864. Divide again. I know the bottom. Oh my gosh, still even. Okay, you would just keep reducing, keep reducing. I'm gonna just use the calculator and get it down to where it needs to go. Let me see if my calculator will even do that. Oh no, it doesn't even want to do that. Well, then this is a good time to show you how to do this on a online calculator. I love Desmos. So you can do the Desmos graphing. Even though we're not graphing here, you still can do it. Or you can do the scientific. If you're in middle school, probably the scientific is the one you'll want. If you're in high school, you probably want the graphing, but they both work fine. Okay, so what I just had there, let me close this file right there. Okay, sorry, that was just bothering me. Okay. So if we just do, what was that? 1, 2, 3, 4, 5, 6, divide a million, because fractions are division, right? There. Boom. There's the reduced form. And see on the right-hand side, that's how I got the fraction. And there was my original decimal. Okay, so you can do this for anything. So let's do 0.94. And then see the to the right-hand side, convert to fraction, boom. And they will already reduce for you. So that's nice. If you have a mixed number, let's do like 3.1. So I would write that as 3 1/10. And then that does not reduce. I bet they'll give us the improper. Let me click the fraction. Yes. So they will give you the improper. So again, you can watch my other video on how to turn mixed to improper, or you might just already know. You do the denominator times the whole number. 10 times 3 is 30, and then you add the top. So 30 plus 1 is 31, and then you keep the same denominator. So this is right, and this is right. This is just going to give you the improper. If you're using graphing Desmos, it's really going to be the same. Mine is mad. Let me tell it to be unmad here. Okay, so let me do that 0.94 again. And now this time your button's on your very left. See that blue button on the left? Click, and there it is, and it already reduces for you. But again, if you have the like 3.1, so that would be 3 1/10, they're going to give you the improper, which is fine. And especially if you're in high school, that's what we're going to be using most of the time. But there you go. So it is fine if I'm your teacher, if you want to use this, it's fine. I want you to see it by hand, but why not use the tools that we've been given? Okay, let me go back here. Let's now go fraction to decimals. So let's go the other way. I would say this is harder, especially if you're doing it by hand, it's harder. Okay, we have two situations. The first situation is not that bad. So this I'm going to call case 1 or situation 1 is when we can easily get the denominator, so the bottom, to be 10, 100, 1,000, one of those, because decimals come as tenths, hundredths, thousands, etc. Okay, so this is the easier case. Now, this is not going to include everything, but if we get one of these, it's generally okay. So let me show you. Let's say we have 2/5, and I want to turn that to a decimal. I can get this bottom to be a 10, right? This is called making an equivalent fraction. And you're going to multiply by what? 2, because 5 times 2 is 10. And then you would multiply this by 2 because you got to be fair. So 4/10. And then the decimal would be 0.4. 4/10. Or you can do the 0. It doesn't matter. This is correct. This is correct. So see, it had a denominator of 5, but pretty easily we can get that to be a 10. Right? How about this one? Let's do 4 9/1,000. So this one already has a good denominator. We don't even need to change it. That's 4 as a whole number, decimal or point, and then 9 thousandths. So no tenths, no hundredths, 9 thousandths. That's all it was to that one. So we didn't even have to change the denominator. It was already good. Okay. Let me do a couple more of this one. Let's do 11 over 25. So that one's not pretty. And by pretty, I mean it needs a 10, 100, or 1,000 or something with in that family as the denominator. But I think we can get this to 100. Think of quarters. 25 times 4 is 100, yes? Because 4 quarters make $1. So let's just times this by 4 and be fair. So 11/25 is equivalent to 44 hundredths, which gives us 0.44 or just 0.44, 44 hundredths. All right, these can be improper as well. So let me see here. Let me think of an improper one. Let's do 51 over 20. So that doesn't have one of our pretty denominators, but what we can do is get this to be 100 if we times by 5. 20 times 5 is 100. So we'll times the top by 5 to be fair. You can just use a calculator or come off to your scratch paper and do 51 times 5. And that's 255. Okay, now convert that to a mixed number. Again, I have a video on this if you need it. Feel free to look in my playlist under middle school math. Oops, I divided the wrong. No, I didn't. Top divide bottom. How many times does 100 go into 255? Well, that would go twice. 100 times 2 is 200. Subtract, and that would be 55 as your remainder. This is your whole number. And then 55 out of 100. And now write that as a decimal. 2 is your whole number and 55 hundredths. So it is possible to have impropers on these. They're a little more annoying, but you can do it. Okay. Okay. I think that's enough of case 1. And now case 2 is if you can't get it to a pretty denominator. So not a pretty, and by pretty, I mean you can't easily get it to 10, 100, 1,000 on the bottom. And this method's going to work for all of them. I'll show you what I mean here. You're going to divide. You're going to do the top, divide the bottom. Okay? So let me show you what I mean. Example 1. Let's do 3/8. Just make sure that's good. Yeah, 3/8. All right. If you try to do what we were doing for case 1, can 8 turn into 10 with multiplication? No. Can it turn into 100? You can try it, but it's not going to work. So this is not easily changed to something pretty. So if you're working by hand, you are going to do long division. So that's why you had to learn that back 4th, 5th, 6th grade. So you're going to do the top, divide the bottom. And you might say, well, wait, 8 doesn't go into 3. No, it doesn't. So what you're going to do is give that inside a decimal and a 0. Carry the decimal straight up. Now, how many times does 8 go into 30? That goes 3 times. 8 times 3 is 24. Subtract, that's 6. And then what you're going to do is you're just going to keep adding zeros. Drop it straight down. 8 into 60 goes 7 times. That's 56. Subtract is 4. Add another 0. 8 into 40 goes 5 times, which is 40. And there we go. Once you get a 0 down there at the bottom, you're done. So 3/8 as a decimal is 0.375. The fancy way to say that would be 375 thousandths. You could also do the 0 in front. Either way is fine. So yep, it's annoying by hand. I will show you in the calculator here in a minute. Okay. Let me show you example 2 here. Let's do trying to think of a good one here. Sorry. There we go. I got it going. 11/40. So again, you could try method 1 where we get this to be 10. Well, you could divide by 4, but if you divided 11 by 4, that's not pretty. You could try to get it to 100, but 40 times what is 100? No, nah, this just doesn't work. So we got to do the second method where we do the top, divide the bottom, long division. But 40 does not go into 11, so you're going to add a decimal and a 0, bring that decimal straight up. And now you ask yourself, 40 goes into 110 twice, which is 80. Subtract, add another 0, drop down. 40 goes into 300 7 times, which is 280. Subtract, which is 20. Add another 0, drop down. 40 goes into 200 5 times, which is 200. So 11 out of 40 as a decimal is 0.275. So fancy way, 275 thousandths. You could also do it with the 0. Now, this method also works for case 1. If you don't want to mess around with having to change it, you don't have to. So let me see here. Let me do 19/25. Now this one we could do the quote easy way. This does change to 100. Again, think of quarters. You could times by 4, and you could times by 4, and 19 times 4 is 76. And then this is 0.76, 76 hundredths. Now, I think that's a faster way to do it, but you do not have to do it that way. Let's take the original problem, 19/25, and let's do the division. This will still work. Let's see if we get the same answer. We should. So 19 divide 25. Well, 25 doesn't go into 19. Add a decimal, a 0, bring the decimal straight up. 25 into 190 goes 7 times, which is 175. Subtract, and that's 15. Add a 0. 25 into 150, count by quarters. 25, 50, 75, $1, $1.25, $1.50. So 6 quarters, which is $1.50. And there you go. Same answer. So if you just want to memorize one way to do it, the division works every time. Okay, let's do it where it would be an improper fraction. And then I'm going to show you how to do it in the calculator, which is much easier. But of course, you know, every teacher is different and they may not want you to use calculator. All right, let's do it improper. Let's do 55/16. Okay, you got 2 choices here. You could go ahead and turn it to a mixed number. So you would do, well, actually, no. No, just go ahead and straight divide it. Just divide. This would be shorter. So 55 divide 16. Now 16 does go into 55 3 times, which is 48. Subtract, and you'll get 7. And now usually you would be done, right? The mixed number would be 3 wholes and 7 out of 16. So if your assignment is turn this fraction into a mixed number, you got it. But we want to turn it into a decimal. So you don't actually stop the division there. You say, okay, how many times does 16 go into 7? Well, it doesn't. So this is where you put the decimal. Go straight up and add a 0. There we go. 16 goes into 70 4 times. 16 times 4 is 64. That's a 6. Add another 0. 16 into 60 is 3 times. That's 48. Subtract, that's 12. 16 doesn't go into 12. Add a 0. 16 into 120. I got to come up here for room. Goes 7 times. 16 times 7 is 112. Subtract, and that's 8. Put another 0. Wee, beep, 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 beep. I'm sorry, this got out of hand. 16 goes into 85 times. 16 times 5 is 80. And there we go. That is the decimal. So 55 out of 55 over 16, the decimal is 3.4375. The fancy way to say that would be 3 and 4,373.75 10,000ths. Okay, let me show you one more that's improper, and then we're going to go to the calculator. Try not to do such a big one this time. Sorry, just trying to find a good one here. Yeah, here we go. How about 7 over 4? So do the top, divide the bottom. Well, 4 does go into 7. 1 time, which is 4. Subtract, that's 3. 4 does not go into 3. So that's where you put your decimal, carry it straight up, 0 straight down. 4 into 30 goes 7 times, which is 28. Subtract, which is 2. Put your 0 straight down. 4 goes into 20 5 times, which is 20, and you're done. So this is 1.75. Okay? If you're allowed to use a calculator, use your calculator. Okay? I wish I would have written down some of those examples because I would have done the exact ones over here. So this is the Desmos Scientific, or if you're just using a handheld calculator, just grab it or your cell phone. 7 divide 4, the one we just did. Boom. Look at the answer right there. Boom. I don't remember what I did before that. It's fine. I think I did 3/8 was our first example of that one. 3/8. Boom. There it is. You can put anything you want in here. 10/40. Boom. Or I guess I didn't hit 10, sorry. 310/40. Sorry, hit the wrong button, but that's okay. There you go. You can put anything in here at all. 9/8. Boom. 11/16. Boom. Okay, and if you're using the other Desmos, just type it in the same way. And I'm hitting on the keyboard, I'm hitting the slash with the question mark. You can also hit the divide button on the calculator. If you're on a handheld calculator, hit divide. So like 4 divide 5. That's all you do. Okay? That's the easy way. Now, all these decimals so far have ended. Those are called terminating decimals. Okay, so all the ones we just got, we got like 1.75 and 0.375 and such. They ended. Okay, and then when something ends, that's called terminating. Terminating is just a fancy word for end. Terminating decimal. And those are the ones we prefer. But that's not all decimals. So we do have something called repeating decimals. And you're going to do it the same way though. And you can't really tell with your naked eyeball which ones are going to be terminating and which ones are going to be repeating. So let's say I have one, oops, I clicked this slide is not the right slide, sorry. There we go. So bring that back. There we go. Let's say we have 1/3, and I want to convert that to a decimal. So I would use the division. 1 divide 3. Oh, but 3 doesn't go into 1. So I'll put the decimal straight up, put the 0. 3 goes into 10 3 times, which is 9. Subtract. It's 1, 0, down. 3 goes into 10 3 times, which is 9. Subtract. 1, 0, down. 3 goes into 10 3 times, which is 9. Subtract, which is 1, 0, down. You see how it's just going to keep going on and on and on and on and on and on. So 1/3 is technically point or 0.3333333 forever. Dot, 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 dot. Forever. Okay? Well, we can't sit here and write this all day. So we have a shortcut of how to write repeating decimals. What we're going to say is 1/3 is 0.3. Again, you can have the 0 if you want, doesn't matter. With a bar on top. That is the symbol. That means that 3 just keeps on repeating forever and ever and ever. Okay? Now, your calculator does not do a bar. Right? Your cell phone will not do the bar. I don't even think Desmos does the bar. We can look in a second. Okay, so you just have to catch that yourself, that this is repeating forever and ever. Put the bar. This is preferred. Okay? Now, some worksheets or teachers might say round to the 100th. So you'd go, okay, 10th, 100th, the 3 would not push. So you would just say 0.33. So if they say round off, that's fine. But technically, the exact answer is 0.3 with the little bar, which means it goes on forever. Okay, let me show you another one. Let me do 4/9. Divide. 9 does not go into 4, so we'll do our decimal straight up, our 0. 9 goes into 40 4 times, which is 36. Subtract, that's 4. Put the 0, bring down. 9 goes into 40 4 times, which is 36. Subtract, which is 4. 0, bring down. Goes 4 times, 36. Boom, that's 4. Subtract, right? It's going to go on forever. So 4/9 is 0.4 forever. And we're going to write that as 0.4 repeating. And that's how you say it too. 0.4 repeating. Okay? I'm going to do one more repeating here. I'm going to do 5/11. 5/11. Divide. 11 does not go into 5. Decimal, 0, decimal straight up. Into 50, it goes 4 times, which is 44. Subtract, that's 6. Drop down, that's 60. That goes in 5 times, which is 55. Subtract, that's 5. Put your 0, drop down. 11 into 50 goes 4 times. That's 44. That's 6. Subtract, or 0, drop down. That goes 5 times, which is 55. And this is going to keep repeating. So this is a 2. It's not just a flat number. It's a 2-number repeat. 0.45454545. So to write this, you would say 5/11 is 0.45 repeating. So the bar over both of them, because both of them are repeating. Okay? Okay. Let me show you that in the calculator. And then we have one more type of these. And then we'll start to compare and order and be done. So we did 5/11. So see, they don't cut it off. They don't have the bar. So you just have to catch this pattern yourself. You can see 4/5, 4/5, 4/5. So 0.45 repeating. Okay. And again, we're just straight up dividing. So I think I did 4/9. Oops. Oh my gosh. There we go. There's 4/9. You can see that 4 just keeps going on and on and on and on. 0.4, repeat. Okay. So we've had terminating decimals. We've had repeating decimals. And now we're just going to have ugly, non-repeating decimals. These you could sit here all day and keep going and going and going and going. Okay, we're not going to do that. Don't worry, but we will go. I'll show you what I mean. Okay, so this is the last situation. We had terminating, we had repeating, and now we're going to have non-repeating. Okay. Let's look at 3/7. So again, you can't really tell with your naked eye what type it's going to be. You're just going to divide as normal. 7 does not go into 3, so we put our decimal straight up, put our 0. 7 goes 4 times into 30, which is 28. Subtract, that's 2. Put your 0, drop down. 7 goes 2 times, which is 14. Subtract, put your 0, drop down. That'd be 8 times. See why you need to know your times tables. Very important. Drop down. That would be 5 times. That would be 7 times. See how this is not getting a pattern and it's not stopping. We could sit here all day and this would keep going. So you go however far your worksheet or your teacher says until you don't see a pattern. This does not have a pattern. It's going to just keep going and then just go dot, dot, dot. So I'm going to say 3/7 is 0.42857 dot, dot, dot. Now, most of the time, we don't typically do the dot, dot, dot to show that it's non-repeating. Usually the teacher or the worksheet will say round, and you just need to follow their instructions on how to round. It really depends on what you're doing. A lot of times we'll just round to the 10th. So if we were rounding to the 10th, that 2 does not bump, and you could just say 0.4. Okay, what if I said, though, round to the 100th? 1, 2, the 8 does bump, so you would say 0.43. Right? So just round to however your teacher wants you to round. Okay, I'll do one more of these by hand. These can be improper as well. Maybe I'll do an improper one yet. Next. Okay, I'm going to do 17. Do I want that? Yeah, it's fine. And I will do 17/13. So it is improper, which is fine. You're just going to do it the same way. 17 divide 13. Now that does go in. 13 goes into 17 once, which is 13. Subtract, that's 4. Now 13 does not go into 4. Put your decimal, bring it straight up, put the 0, bring him down. 13 into 40 goes twice, which is, no, 3 times, which is 39. Put your 0. Ooh, that doesn't go. Put another 0. So that 13 does not go into 10. So I put a 0 at the top because it does not go in. And then put another 0 to make that 100. Now 13 goes into 100 7 times. 13 times 7 is 91. Subtract. 13 goes into 96 times, which is 78. That's 12. That does not go into 12. 13 does not go into 12. So put a 0, put a 0. And see, we're not getting a pattern here. This, we could sit here all day. And it just keeps going and going and going. So this is a non-repeating decimal. So technically we could say 17/13 is 1.30760 dot, dot, dot to show that it is not repeating, not terminating. It just keeps on going. Okay. It should be a 9. I don't know. I goofed my division. It's fine. Good enough. Okay, but again, usually your teacher may say round, that's the abbreviation for round, to the 10th. 0 does not bump, so you would just say 1.3. If the teacher says round to the 100th, the 7 does bump, so you would say 1.31. Okay, so round to however your teacher says to round. Okay, let me show you these in the calculator. So I just did 17 over 13. There he is. See how ugly it is. And then you can just round to however your teacher wants you to round. Let's do 5 over 19. I didn't actually do that one, but see, that is not terminating, not repeating. You would round however the teacher says to round. Okay? I got one more thing to show you. Comparing and ordering. All right, let me find a good problem here. Righty, let's do 0.6 compare to 5/8. So you want to turn them into the same unit. They either need to be the same, they both need to be fractions or they both need to be decimals. I think it's easier, well, it depends on if you're using a calculator or not. I'll do it both ways. So if you're going to do it both fractions, the 5/8 is already a fraction and you want it reduced, and so it is 5/8. And then 0.6, the fancy way to say that is 6/10, but 6/10 reduces, they're both even. 3/5 compare 5/8. So we're still comparing. And by comparing, I mean greater, less than, or equal. Okay, but now you can't compare those because they don't have the same denominator. So think of a common denominator for 5 and 8. That would be 40. I'm going to turn these both to a denominator of 40. This we had to times by 8, so that would be 24. This one we had to times by 5, so that would be 25. And now you can compare, this one's bigger. 25 is bigger than 24. I mean, that works, but it's annoying. I honestly think it's easier, probably, especially if you're using a calculator, to just do both decimals. Okay, so let me clear that. Let's do both decimals. Both decimals. So 0.6 is already a decimal. Compare, and then do 5 divide 8. So if you're using your calculator, just do 5 divide 8, write down the decimal. If you're not using your calculator, come off to your scratch paper and do the long division. And the decimal for that should be 0.625. Now, a lot of people are like, wait, I can't compare them. One's only 1 digit long and one is 3 digit long. What you can do is you can add zeros to the shorter one. There you go. So we have 0.600 and 0.625. Which one's bigger? There you go. So if you're allowed to use a calculator, that decimal way is certainly easier, but it just depends. You can do it either way, doesn't matter. Okay, I would like to do 1 and 2/9 compared to 1.2. Okay. All right, so if we're going to do both fractions, the first one already is a fraction, and the other one would be 1 and 2/10. But 2/10 reduces. You can divide by 2 because they're both even, so that would be 1 1/5 reduced. You can just leave the ones, they're fine, but you want to get the fractions with a common denominator. So common denominator of 9 and 5 would be 45. 9 we had to times by 5, so we'll times this by 5, so that's 10. And 5 we had to times by 9, so that's 9. And now this one's bigger because The 1 is the same, so we're really just comparing the fractions. 10 is bigger than 9. And you're only comparing the top once you have the same denominator. Again, it works, but I don't know. I would rather just get them to be both decimals. So the 1.2 is fine. Compare. And now in your calculator, if you're doing the calculator, you're just going to keep ignore the 1 and just put 1 point and divide 2/9. So do 2 divide 9. So that would be 2 repeating. So again, in your calculator, that's 2 divide 9, and that's going to come out as 0.22222. So that's why I said 2 repeating. Right? And again, the 1, the whole number just stays. And now here, it is a little tricky to know which one is bigger or smaller. But again, with the repeating, this has just 2's coming forever, and this technically has 0's coming forever. So the 1 is the same, the decimal is the same, the 2 is the same, the first 2, but then after that, this guy's got a 2, this guy's got a 0. Bigger. 2's bigger than 0. So you just keep comparing until you get something not the same. Okay? Either way is fine though. Let me find one that's like a non-repeating and non-terminating. Okay. I'm going to do 16 over 7 compare 2.25, but repeating. So that'd be like 25252525 forever. Okay, if you want them to be both, now here, the repeating to get it to be a fraction is pretty difficult. So I actually would not even do that. I would just go the decimal route here. So we're going to keep the 2.25 repeating and then do 16 divided 7. You can either come off to the side and do your long division or do it in a calculator. Now it is ugly. 16 divided 7 is a non-repeating. So it's like 2.2857, blah, 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 blah. Okay. So I'm going to write 2.2857, blah, 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 blah. You may not need to write all that. And now let's compare. So the 2 decimal, 2 decimal, 2, 2, 8, 5. This one's bigger. 8's bigger than 5. So you really didn't need to write these digits, but it didn't hurt you to. Okay. All right, and then the last thing I want to do is order some. So let's order from least to greatest. Okay. I have 3 numbers here. I have 4/9, 0.4, so 4/10, and 5/14. So again, I would probably just go ahead and put them all to decimals. I think that's going to be the easiest thing, especially if you're allowed a calculator. So if you're not allowed a calculator, you'll just do your long division. Okay. But if you are allowed a calculator, 4 divide 9, this is one of our repeatings. It's 0.4 or just 0.4 repeating. This one already is a decimal, so just leave it. And then in your calculator, do 5 divide 14. It is a non-repeating, and it's 0.357, blah, blah, blah. I would say just chop it off at 3 decimals. It's fine. And now we want these least to greatest. So who's smallest? And sometimes it's easier to line them up vertically. So we have 0.4 repeating, 0.4 by itself, and 0.357. Again, you can put the zeros or not. So who's smallest? Well, all the zeros match, all the decimals match. You always want to line up with the decimal. What's the smallest number? 4, 4, or 3? 3. So this one's the smallest. Okay, so scratch that out. Now, which one's the next smallest? So a lot of people are like, okay, what's the difference between 0.4 and 0.4 repeating? So the repeating technically has fours forever, and the one by itself has zeros forever. So even though these fours match, this is a 4, this is a 0, so 0 is smaller. This one's smaller. So this one would be medium, which means by process of elimination, this one is big. Okay, so this one was big, this one was medium, this was small. So small, so least to greatest, so smallest, medium, largest. That's how they should be, least to greatest. Okay, I'm going to do just maybe one or two more of those. Okay, let's go least to greatest again. I'm going to have 4 numbers this time. 1.62, 21 over 11, 1.094, and 1 3/5. So again, I would go all decimals. So this first one's already a decimal, so we're just going to leave him. And so is the third one, 1.094. Okay, either calculator or scratch paper for long division. That middle one, you're going to do 21 divide 11. So when you do that in the calculator or long division, it is a repeating. It's 1.90 repeating. It keeps going 909090. Okay. And then on the last one, keep the 1, and in the calculator, just do 3 divide 5. Or if you're long dividing, just do 3 divide 5. So this is going to be 1.6. 3 divide 5 comes out as 0.6. Okay, now we can compare. And again, it is often useful to go ahead and line them up vertically. So we have 1.62, 1.90 repeating, 1.094, 1.6. And if you don't like how they're not the same length, you can just add a 0 there, zeros here, and now see the 90, that's repeating. So that would be another 9 because it's 909090. You don't have to do that, but if it bothers you that they're not the same length, you can. Okay, so all the ones match, all the decimals are in a line. What's the smallest number? 6906. 0. So this one's smallest. Okay, or you could say first. Okay, what's the next smallest? 696. Okay, well, we have 2 with a 6. So go to the next digit, 2 or 0. 0. So this one's next smallest. So this one's second. So we have just the top 2. We have a 6 and a 9. Well, 6 is smaller, so this one's third. And the 9 would be fourth or biggest. So smallest, second, third, and biggest. So it takes a second, not too bad though, if you can use a calculator to help you get all the decimals. All right, that's what I would recommend. Just turn everything to decimal and compare that way. All right, I hope this was helpful and that you're having a great day. If you have any questions, just leave me comments below and I'll get back to you. Bye-bye.